Okay, everyone. So welcome to this month's meetup. It's a .NET Liverpool meetup, and luckily with virtual at the moment, so we get speakers from all over the world. So I'd like to welcome Oskar, and thank you for coming to present for us today. If you're not familiar with our group and you've just found this is the first time you've joined our group, you can learn a little bit more about us. We have a YouTube channel where we record all of our meetups every month. You've probably seen our meetup page where we publicize a lot of our meetup events that are happening. So do check that out and subscribe. We've also got Twitter and GitHub. So if you're interested in sort of developing that open source community, we're part of the .NET Foundation. So we're highly active in trying to, collaborate and support open source work. So yeah, do check us out. And if you've got any questions, just let us know. Can you all see my screen? Should have asked that first.
Yes.
Fantastic. Yes. So this event wouldn't be possible if it wasn't for our sponsors. So they help us maintain our websites, allow us to bring in all the great creators as well to help us publicize what we're doing. So a big shout out to TLA, who are based in Liverpool. They're a software development company, and they work in lead generation. And they usually cater for things like our catering costs, food, website, merchandise that we give away. On the other side as well, we've also got JetBrains, who are one of our sponsors. And they've given us away some JetBrains licenses. So if you are into the .NET development side of things, you'll find that they do a lot of great plugins like ReSharper, and they do a lot of stuff around JetBrains. So there's a load of things you can get for free. We're going to do a giveaway today. So just drop us a message privately to me or Chris with your email address, and we'll put you in the raffle for the end of the session. And we've got a new team member who's joined .NET Liverpool as well. So a big shout out to Christopher Daly, who's joined to help our team expand. So going on from next month, we're actually going to start running physical events again. So it's been a long time coming, over a year now since we've run an actual physical event. And we've loved having virtual events because it means we can grab speakers like Oskar from all over the world. So it's been absolutely fantastic. But if you are around the Liverpool area or you want to come and visit us next month, we're going to be hosting a virtual event, get some pizza, and have a little bit more of a collaborative session, have some beers, and just get to know each other a bit more virtually within the guidelines as well of COVID, obviously. So it'd be good to get that back going. And just a kind reminder that we are going to put this on YouTube. So any questions or anything like that, we'll be putting our YouTube channel. So just try to keep the language and everything, as audience appropriate. And I'll leave that there. So I'll pass you over to Oskar to start us off. Thank you, Oskar. And
thank you.
Stop my screen.
Okay, let me share mine. Can you see the screen?
Yes, we can.
Yeah. Okay. So let's start. My name is Oskar Dudycz, and today I'll be doing a practical introduction to event sourcing based on EventStoreDB as an example. So few words about myself. I'm a developer, technical leader, and architect from over 14 years. And currently I'm working as a developer advocate at EventStore, where we are creating a database built for storing and processing events. I'm also active open source community, and I'm also co-maintainer of Marten framework. Marten also is related to event sourcing, but also allows to use Postgres as a document database. But today we'll focus on EventStoreDB. Before I go into hands-on mode, because this will be a really hands-on experience, I would like to just do a quick theoretical introduction so we have alignment with our knowledge. So let's start with the basics. So what is an event? An event represents a fact. So it gathers an information about something that happened in the past. So for example, Eagle has landed, or I went to the pub, or I attended .NET Liverpool. And events by its nature are immutable. You cannot change the past. Of course, if you were reading 1984, then that might not be so obvious and so true, but in general, without bigger manipulations, past cannot be changed. But so we can ignore some facts, like, for example, that some political party won, but we cannot retract them. So we can ignore them, but we either have to pass it along, but that doesn't change the fact that they happened. So what has been seen cannot be unseen. And we can interpret events differently. So for example, if there is a football match and one team wins, then fans of that team are extremely happy, but on the other team, not so much. So the same event, the same fact, but has a totally opposite interpretation. And events, of course, are messages, which is quite critical to why we gathered here, because they can be modeled and coded in a code. And that's one of my favorite quotes. It's from Greg Young, which is also one of the co-creators of EventStoreDB. So if we are starting to thinking in our system based on events, then we are getting closer to the business behavior, and that helps us to change our mindset, to stop thinking about the typical classes tables, but we are more thinking about the workflow of our system. And that's something that is, for me, the most important fact about using event sourcing and in general event-driven architectures. And that was also noticed by Alberto Brandolini. So he created the event storming methodology, which allows to model system, not only event-driven, but also in general, based on the events. So we are putting those orange sticky notes that are some checkpoints of our workflow. And based on that, step by step, we can be modeling and getting understanding of our business needs. And what's also important about events is that they help to create a communication between business and developers. Okay, yeah, so this is Alberto. And there are different artifacts that can be used to model system. So the most important is called domain event. So that's an event that represents something that happened in our system. But we also have, of course, comments, that events are the results of processing comments. We can have aggregates, read models, and also some business logic. And Alberto created such drawing, which he says that explains all possible ways that can happen in system. So we are sending a command, then we are checking some business rules, or we are integrating with some separate system, and then we are getting event as a result of that processing. Based on the event, we can either update read model, or we can send processing to another business rule that will trigger a next step of our workflow. And besides events, a really important term in event sourcing and event-driven system is event stream. So event stream is an ordered sequence of events. But why is it called streams? Because if our system is alive and it's ongoing, then it means that if we have a look on our stream, then between the previous look and the current one, probably new events were recorded. If in our system, no event is recorded, then that means that either no one is using the system or we have some serious bug. So that's why stream, because that's a continuous flow of events. And event stream can be a picture like that. So we have timeline, and each new event is appended at the end of the event stream. So event streams are also immutable. We cannot just delete events that happened in the meantime. If we want to revert something, then we cannot just modify the stored event or delete it. We need to provide another operation and another result of an event. That might look a bit tedious, but it's closer to the real life, because if something happened, then as I said, we cannot change it, we can only fix it. So for example, if we are generating invoice, we cannot just remove the invoice and send a new one. We are just sending a correction. So new copy of the invoice. And each stream represents a separate object. So for example, if we have 2 shopping carts, then that will create 2 separate streams. So typically streams represent a specific object, entity, aggregate. So we can think about the stream like in a classical way as one record in the database table. But thanks to events, we have more information. We are not losing any data, because in traditional approach, we are just keeping the last state, the current state of our entity, while with event sourcing, we have the whole history of business operations, and that gives us few benefits. So, but in general, even though we can split our events and group them into the streams, so into our entities or aggregates, in fact, in majority of implementation, we have something that is called an append-only lock. An append-only lock in event stores is just like events are always appended to the same logical and physical storage. So thanks to that, we are getting the global ordering, because as you see, those red boxes are from the one stream, but and the violet one are from the other one. So we not only know what's the order of the specific events that happen for the specific record, but we can get also the global history of our operation in our system. So that's kind of cool. And what's event sourcing? Event sourcing, the name comes directly from the fact that in event sourcing, events are the source of truth. So all of the others, other data and other data structures are just derived from the events. So we can erase, in theory, all of those other storages as long as we keep this, event log, then we can always regenerate them. And what's quite crucial in understanding event sourcing is that it's, as I said, contains an ordered history of our operation. So if we have a look on the shopping cart, then at first we are initializing the shopping cart, then we are adding new product, and then we are maybe removing because we decided that, yeah, we did it by mistake, and then we are adding a new one. So like, for example, instead of Cyberpunk, we decided that now we will go with The Witcher. And at the end, we are confirming cart, and from now on, the cart is changed into the processing order. And nice thing about event sourcing is that we are able to do the time traveling. So if we have the recorded sequence of events, then we can always go back. And so we can, as you see, we can just take the events, apply that to the current state, and get back in time to see what has happened. So because of that, we are getting the increased features about debugging, which for us developers is kind of cool, because maybe we are not caring about the business. We don't care about sticking orange sticky notes, but event sourcing is making our life easier, because we can take events from the test system or from the production. And thanks to that, we can see what has happened if we have a bug. And as I said, we can just take a subset, because we know that someone complained that the product was removed from his cart, and then we know that in fact he did that. So that's kind of cool. Besides that, besides debugging, we have also increased auditability and tracing. So if we have a look on this set of events, then if I align those events like that, and we are humans, then we can interpret them easily, that those events happened in a specific order, or we can guess what's the desired order. But computers don't work like that. If we don't store information about when they happen, what's the order, what's the relation between them, then even we may be just guessing, but computer systems don't understand that. And in event, we can store also the correlation. So if we store in each event with the metadata information about the entry comment and entry request and pass it to all of our processing, then based on the correlation, we can search and find all of the events that happened for the specific request. And thanks to that, we are getting the traceability. And we can also store the causation. So if we send for example, as a causation ID, event of the event ID of the event that get triggered the next step flow, then we can build also like a dependency tree. So for example, if we get event ID from the for the card confirmed and store it as a causation ID for card confirmation, then we know that this event happened based on the previous one. So it was triggered. So thanks to that, we can build such a nice tree. And if we match correlation and causation, then we can get like a full understanding of what happened in our system, which for distributed system is especially important, because then even if we have logs, then going through logs in distributed system is incredibly hard. And let's talk about the event sourcing architecture. No, just joking, that's not a event sourcing architecture. If you see such a picture, this is the picture taken from the article in internet, how to build event sourcing system, then start to be suspicious, because probably you might not need like a 90% of things that are in this picture. So maybe this one, no, that's unfortunately not this one. And this is from today's article when someone is explaining how to build event sourcing system. So if you see that you need a message queuing, if you need the eventual consistency, then start to be suspicious. Usually it means that someone is mistaking event streaming, so processing events, moving them from one place to another, with the event sourcing. So what's in fact event sourcing? Event sourcing, we can simplify and say that, well, it's just a storage pattern. So I'm not precisely agreeing with that, but by its nature, event sourcing is about storing events and then getting the state out of those events. So if we are receiving comments, then we should get from an event store. An event store is a database, in fact. So it might be event store based on Postgres, might be EventStoreDB that's built for storing events, but still it's a database. It's not a queuing system. So you are taking on demand all the events that happen for the specific object, and then you are creating a default object, for example, with the default constructor, and one by one, you are applying the events one by one to build the state from those events. So as you saw, if we go with the shopping cart, then we could even visualize that with, as I did in the previous slides. So after we build the state, then we are running the business logic, and our result is a next event. So that's kind of crucial, because of most of the queuing platforms do not allow to on-demand get the events. You can just create a snapshot, which is just a temporal representation of the events. So this cannot be named as event sourcing, because events are not source of truth. They are just triggers to updates with models. So that's the most important to understand. And events, as I mentioned, they are messages. So they might be represented, for example, as a JSON. So stream ID is for, in our case, it's a ID of our record. then we can have serial number or position or version, depending on event store that might be named differently. It's in fact the number order of appearance of the event in event stream. Of course, we might have timestamp or other metadata, but the most important is that we have data, and data contain information about what has precisely happened for this business operation. And we can store such data even in the relational database, so just like Marten is doing, or you can store it as a binary format and put it into disk. So as I said, like a traditional regular databases, because all of the databases may be MS SQL, may be Postgres, are in fact storing all the data as disk files. And that's precisely what EventStore does, because as I mentioned, it's a database and it's storing data directly on a disk, of course, with some sophisticated logic, but it's just a database. Okay, so that will be for now all about the event sourcing theory. Let's go to the code. And I forgot to tell you that if you have any questions, feel free to write them on chat. I will try to answer all of them, or most of them at least, during the presentation, but some of them I will leave for the end, but feel free to ask. I will try to be looking at that. So let me open the IDE and let's try to code to understand what's event sourcing all about. So let's start with defining an event. So events can be defined as just the data transfer objects, because events, as I mentioned, are messages. I'm using the latest, greatest syntax record, just to simplify. You can also use class, structs, whatever. But what's the most important is that, as you see, if we can, based on event, we can model the whole workflow of our specific entity or our system. So in this particular case, I'm modeling workflow for the shopping cart. So we might have events like a shopping cart initialized, the product item was added to shopping cart or was removed, and at the end that shopping cart was confirmed. What's important, and what you might already notice, is that all of the information are correlated by the same ID. And this ID can be used as a stream ID, which will end up in a traditional way as a, for example, our shopping cart entity ID. All of them has some specific information, for example, that it was initialized for the specific clients and it was then, for example, pending. We don't need to send information about client in the follow-up events because we already have that information recorded, because in general, we should try to keep the events as small, but not smaller. And then we have some data about the product item that we selected, which is again, like some simple value object that has information about the product ID, about quantity. Those messages, those static methods are factory methods. I like to use factory methods to initialize and do some simple validation to then make sure that created object is following the rules. But you can just focus on the data. And yeah, we have also product item list, which is again just a value object for processing product item. Like for example, if we are adding product, then we are checking whether we have already such product in our item. In this case, we are just increasing the quantity. If not, then we are adding it. For remove, it's exactly the same. So, but we won't be focusing today on like a specific coding syntax. or DDD practices, but see, those objects are just simple transfer objects. And let's define our entity, because we won't be just doing our business logic and our processing based on just events. Events are a base for that, but we still can do a similar approach as a traditional way. So let's define how our shopping cart would look like. So shopping cart will represent the current state of our cart. So it will contain probably all the information that were stored in the specific event. So we have ID of the shopping cart, we have client ID, we have current status, current product items, and also nullable information about the date when it was confirmed, because this will only come with the end event. So how to build and how to get the current state from those set of events, from the sequence of events. So we can build a method. Typically it's named when. We can call it also apply or whatever you prefer. It will take the current state of entity and new event. And based on that, one by one, we will be calling that method event after event that we loaded from database. And thanks to that, we will gradually build our state. And we can use a pattern matching. And I will show you the syntax that for me, it's like, I have it with it like a love and hate relation. I'm wondering whether for you it's more love or hate. So please comment. So as we are using the records, let me just scroll it so you see whole method. So as we are using, I'm using C#9 records, then we have the deconstruction of our object. So when our cart was initialized, then our entity will be null, and we should create a new record, new object based on data from the event. So as you can see, I deconstructed our event and just passed this information to newly created shopping cart. And I'm also initializing product items as an empty list. Then for when I'm adding the product, then I'm just taking the product item. I don't have to take the cart ID, and I'm adding it to the list. And then I will get the entity that was created in the previous step. And if I had an event that someone removed the shopping cart, then I just have to change it, remove the product item. And for confirmed, I just have to change the status to confirmed and set a confirmed add date. And this is quite, in my opinion, this is quite readable, and it's also a documentation how we applying our state. So if you are not familiar yet with C#9, then with and records allows to create an immutable data. So if we are getting the entity, then we are generating a new entity with the changes that we defined here. So I'm not precisely happy with all the stuff that was added in C#9, even with this switch syntax, but I believe that for this specific case, it's kind of cool. So again, when we are having the first event, then we are creating new entity. Then for the next one, we are taking this entity and, for example, applying, adding new product, or we are confirming our cart, and that's all. So how to use this method? So we can do it like that. Let's scroll up. And let's define some sample code, like a client ID, a shopping cart ID. We will define that we would like to buy a shoes or maybe t-shirt. We'll see in a minute. And we get a list of events. This list might be taken from the database, from EventStore. but I'm just using here to represent it. We will go further how to use EventStoreDB to retrieve events, but let's now focus on the specific lifetime of our object. So we can think about our current entity as just the identifier and all the events that happen for this particular object. So at first, we initialized a shopping cart, then we decided that we would like to buy shoes, and then we added t-shirt, but then we realized that we don't have enough money, so we have to resign from shoes and we remove it from the shopping cart. And then after that, we confirmed and have decided to buy a fabulous t-shirt. And if we have this set of events, then we can also use a linku, like an aggregate method. And we are defining that as an initial state, we are using default shopping cart. So it will be a null. So if we get a null, then it's safe because we should get the first event shopping cart initialized, and then we are returning an shopping cart. And for each of those further objects, it will take the aggregated state that we are returning from this method and then use it for the next apply. And so we are just aggregating state based on the when method. And let's try if I didn't make a mistake. Let's just copy the hello Liverpool to the top. That's also something from the from the .NET 5, the single file. Let's run it and see if we have only t-shirt. And yeah, we have only single product item, which is unfortunately we just need to. You have to believe me that this is a t-shirt, but yeah, we can check, for example, based on quantity, it's 2, so it's a t-shirt. So that's kind of cool. Any questions to that? I don't see any questions. I, again, encourage for adding that if something isn't clear. But let's try to understand how we are generating events, because we already know how to build the state from the events, but to have those events and to retrieve the state, we need to somehow store it before. So for that, we can use such logic. So initialize shopping cart is a command. Usually in event sourcing, we have one-to-one relation. One command is generating one event. It doesn't have to be like that. It can generate multiple events, but 99% it will be such a mapping. Again, I have this factory method that you can ignore. It's just validation. But I also like to keep, in general, methods that are changing together within the same file and in the same place. Then I'm just not having so much context switching. And in this particular case, I'm also having the handler method. So handler is taking just a command, is not taking any state because we don't have state if we are creating new shopping cart. And after that, we are just creating new event based on that. So we are just passing data from command and creating a specific status. So that's the dummiest command handling that you can imagine. No business logic. If we can name it business logic, then maybe we are quite optimistic. So let's define something more advanced. So for example, adding product item. So in this case, we need to check whether the shopping cart is already open. We may also inject some specific class, and we also have the current state, because if we are adding the item to the shopping cart, then we have to have that shopping cart initiated. So we are taking the data from command, we are taking product item, and in this particular case, product item is a just quantity plus product ID. And after we calculate, we get a price product item that we are passing to the comment. And again, if we can define accordingly the command handling for removing a product item from shopping cart. Again, data, validation, and again, that's a similar logic, but we are, instead of adding, we are removing. And the main logic would be even more sophisticated. I offloaded some of the business logic and some of the verification to the value object. And that's in general something that I would still also recommend. And let's get back to our code.
We have a question, Oskar.
Okay. This example shows entity state modification. In real case, we would be doing that by calling, like, suppose, yes, we should be calling the async method. I will show it right after we go through those handlers. So I would be grateful if you then can confirm or not if that answers your question. So again, the last one would be confirm shopping cart. Nothing fancy. We are just making sure that we are confirming open cart and creating an event. So that's a common pattern. So either we are taking a comment without a state if it's initializing the first comment that we expect for our entity, or we are taking a comment with a current state, and then we are returning an event. So that's kind of clean. And what's the most important for me, that it also allows easier unit testing. Some people says that event sourcing is hard to unit test. So for me, having such method is like the most easy thing to do, because we have immutable. This is pure function. We are just taking parameters and returning the result. So for me, that's the easiest code to unit test that you can imagine. Okay, so now I will go to this asynchronous processing and to EventStoreDB, because that doesn't look still like a real application, right? So we'll use, again, wrong copy paste, sorry. So we will, what's the most typical class? Repository, of course. So we will use it to make it like a more real life. So we will define an EventStoreDB repository for our specific entity. So in this case, it will be shopping cart. And we will have following methods. Find, that will return the entity if it exists. And that will take as a parameters our when method, ID of our entity of our stream, as we will see, and two methods for appending. The first one without version and the other one with a version. So that one will be used for example, initializing shopping cart. So for the first event, and the next one for the optimistic concurrency, because that's also something event sourcing is different from the event streaming, that you have all the guarantees that you have in the regular application. So you have strong consistency on storing events. At least most of the major event store I know supports that. If you append an event, then immediately you see it. It's a strong consistency. There is no eventual consistency. And you can also be sure you can use optimistic concurrency. That's not possible, for example, in Kafka. Because in Kafka, you can just subscribe to topic, get data. If you are storing event, then either it's stored or not. You cannot verify optimistic concurrency, and that's making the logic harder. So let's see how EventStoreDB repository is done. So we are using EventStore client. It's a gRPC client. And to read the events, we are using readstream async. So See, there is async, so that's a serious enterprise application. No dummy data. And we can, like this method has a lot of parameters. So we can read stream forwards or backwards. Typically, we want to read from the start till the end, so forwards. But we could also do it the other way around. So we could do like an end and backwards. And then we will read from the last event to the most recent one. We can also define stuff like maximum number of events, etc. So if we would like to get just the last event, then we will use max count 1. And having such stuff would just read out the last event. But typically, as I said, for our business logic, we are just reading all the events from the specific stream, from the specific ID. And after that, when we get the result, then we need to deserialize all the events. So events can be stored in a JSON file or binary, JSON format or binary format. In the end, they will be stored as a binary data, but that can simplify some processing. I'm using here JSON, so nothing fancy here. I'm just taking the event type from the event returned from EventStore, and I have some event type mapper that just takes me the event type, formats, replace the underscores with dots, and then just try to load it from the assembly. So that's the only place where I'm using reflection in the code that I will be showing. But in general, the logic is simple. We are just taking events, we are deserializing them, and after that, see, we are calling again the same method but asynchronous. So previously we were calling aggregate, and we are calling aggregate async because EventStore is returning as the async enumerable. Read stream result implements async enumerable, so it's performance efficient. And we can pass the when method, and that will be used like that. And for append, again, we have append to stream method. This time we are serializing data into JSON. And for the newly created event, we say EventStore that we expect to not have stream, for example, for initializing shopping cart. And for the other method, we are passing the version, and we can have optimistic concurrency, so we can have all the typical processing bits that we have in our applications. So does it answer your question, Prasad? I hope that it is. Please, would be grateful for confirmation. And I also encourage others for raising some questions or doubts. And let's see how this will look like in EventStore. EventStoreDB gives you the dashboard. So you can see some like a technical parts, information, what's going on, but you have also the stream browser. So I have already created some streams. As you see, they are recently created. Some of them with those weird dollars are not that they are extremely important or pricey, but they are internal. But let's have a look on the stream. So as you see, all the events are auto-incremented position. They also have the type. So as you see, I'm just replacing the dot with the underscore, but this looks like a type definition in our .NET. It's not precisely safe to tie it up together, but for the brevity, I use it like that. And we can also get to the specific event and see the data that we added, some metadata, event ID, and timestamp. And we can also go through all the events. So that's what I said. And important thing to see here, if we go again to our streams, is that our stream is built from this is the GUID ID that we were using as a shopping cart ID. And we also have to use prefix because we might have different records with the same ID. So typically the convention in event sourcing system is to have like a shopping cart. So this is the prefix representing the type of our stream. Then we have some split. And then after that, we have the event ID. This is kind of close to modeling the key in the key value stores, because in fact, event stores are also key value stores, right? So yeah, we also have just the last thing that I would like to show you. $all. I will probably, yeah, sorry, not that one. Okay, let's skip it for now, but you can also browse through the all stream, and then you will see all the events in the order as they were created. And if we would like to define our pattern for how to generate our stream ID, then this could be done like that. So we could have like a again method in the shopping cart, yeah, over here. And we could also define that if we take a shopping cart ID, then we would create such a stream ID. Of course, we can make it more sophisticated, more generic, but that's up to you to do that. But I typically prefer the simpler, the better. Again, question. Yes, thanks for explaining. One more doubt. Just curious, would we face thread issues when we do event processing like that during in hot path scenarios? So that's why I suggest to use optimistic concurrency, because that enables you to make sure that you are always making decision based on your current state, and the event store client is thread safe. So that should handle your. So how to model comments? So we can have like a static method. So that's a typical scenario. So handle create comment. We are getting an event entity ID from comment, and then we are running the handler, and then we are calling the repository to append newly created event. And for update, we need to call it first the repository find, then we are running the handle logic, and again, we are appending with the version that we take from comments to support the optimistic concurrency. And we can also define such helper methods that will take a service collection. We can register all of that in our dependency injection. So we can inject that into our current workflow. As you see, I'm not using any marker interfaces. All of that will be hand checked at the verification. And based on that, we can define such a module configuration. So we are registering event store repository. We are using our helper to say that for this particular comment and this entity, use this handle method, which as you see, I defined previously. And then for update command, we define that we would like to, for example, inject from the dependency injection, the product price calculator. So we can still inject some services like I did here to calculate prices. So we are not limited, but we still have pure function that is easy to test, to mock the service, etc. So that's, in my opinion, it's quite clean. And we can define the same for the other methods. And as you see, I'm mapping here the shopping cart ID into the stream ID. So just a simple registration that can be used also for the for the modular definition and documentation. So let's get back for a moment to slides and discuss how to build read models. So projections are the different interpretation of the same event. So this is, as you see, Muhammad Ali that just knocked down one opponent. And this is the fact. This is event that happened. But as you see, Muhammad Ali has totally different interpretation of this specific fact than his opponent. So exactly the same is for projections. So we can have the same information, but interpret it differently. And projections typically are used to create some materialized views. So our to use it later on for our read models. So for example, we can take this subset of events like the event stream and then store it as a single record in the database. Might be relational, might be document, whatever. And we can also use it for the different streams. So for example, if we would like to create user cards dashboard for administrator, where you see all the users and the shopping carts, then user will be probably a separate stream than a shopping cart. So we can still take all those events as we have this unified all log and merge them together into some unified read model. And typically we are handling projection with a left fold, and left fold is comes from the functional approach, but it just means that we are taking this the current state and applying event after event. So for example, we are taking cart initialized, then we are creating new record, newly materialized record. And then when we get a product added, then we are updating the products count. And when we getting cart confirmed, then we are updating the status. So we can create different read models based on the same set of events. And yeah, when you were looking at the aggregating state, then that's also projection, but it's getting the projection projected state into memory, and we are using that for our business logic. So projections do not say where do we store events. It just means that we are taking some set of events, interpreting them, and doing something afterwards, like storing or updating new record in the relational database. And that can be used for queries, of course. And as I mentioned, product added might update various read models. So based on the single events, we might get multiple updates. So for example, we are updating our shopping cart, as you saw. As I mentioned, we can update some user dashboard when we see all of the products that user has in shopping cart. And we can also update the product availability, because if we added product to shopping cart, then probably we reserve it and someone else shouldn't update it. So as you see, single event, but can trigger multiple different updates to read model. And that's also powerful because we can focus on the right model on how to store event, how to perform the business logic. And then having this event, we can think how to build read models from that. And for me, when I was doing classical approach, that was always hard because I always had to think on everything. Like, okay, but if I add this column, then this foreign key will break, and what I have to do. I think that any of us can relate to that. Here, of course, we can have these issues. It's not like a magical silver bullet, but we can split those considerations into steps and focus on the particular one. So for me, that's also powerful how it's impacting our developers' life. And projections may also create other events. For example, if we would like to publish event to external system, then usually we are mapping the events to build like a more fatter state with all the information. Projections doesn't have to be asynchronous or eventual consistency. Like for example, in Marten, we are storing events and we can update all the the projections at the same time. So, but of course, this is limiting the performance. So typically we expect our read models to be eventually consistent, so be updated after some time, after we run the business logic, but that's a performance consideration. And that's also the fact for the EventStoreDB, because currently we don't have built-in read models. So we need to offload it, as you will see later, to the databases that are built, for example, Elastic for full text search, Mongo for document approach, or Postgres for relational. So, but that enables like a bigger fault tolerance, etc. So EventStore has a functionality that's called subscription, and it's similar to change detection capture in traditional databases. So EventStore will notify your service that new event was created. You don't have to continuously pull the data from the database and check if there are new events. But you will be notified, and based on that, you can trigger next steps, like you can update read models, you can even forward this event to Kafka or Rabbit, or integrate, do any other business logic based on that. And projections are also deterministic. As I show you, usually they are pure functions, so we can unit test them, and for the same set of events that will be always the same. And that means that we can rebuild those read models. So in the easiest way, we can erase, truncate the current read model and apply the events again. Or we can build a blue-green rebuild, so we can take the current set and use it still as for the querying, and then create the new read model with the same structure, but without data, apply the events, and then after we are up to date, then we are switching the read models. The obsolete that, for example, could have broken data will be moved out of fashion, out of use, and we will be using the newly created read model. So it's kind of powerful pattern also. And again, let's do some coding, but this time I won't be coding much more. I'll be showing you how to use it, because we don't have so much time. So let's define, let's see how we can model two different read models based on the same set of events. So one will be like a shopping cart details, where we have all the information. So that's, for example, used for the edit screen, right? So you would like to see all the information. And we would like to have also read model shopping carts short info. And short info will just have like a total price and total items count and status, no detailed information about products. That's a typical use case, because list usually contains less information. And that's also quite important because, for example, this read model could be stored in Elasticsearch, because we are using list to search, etc. And the other one we could store, for example, in the Postgres or Redis or whatever. So we have a lot of flexibility. But I will use here only Entity Framework and Postgres, because I would like to show you that you can integrate event sourcing with your current solution. It doesn't have to be like an extreme revolution for you. So it can be easily integrated. So for the shopping cart projection, we can define separate handlers that will be doing the event processing. And again, it's a similar pattern as previously. So we have, for the shopping cart initialized, we just have an event because we don't expect to have the state. We are creating the new object and just storing. But for the further handlers, like a shopping cart confirmed, added item to shopping cart or removed, we just updating the view that we are passing here. And The same will be done for the shopping cart details, but a bit more sophisticated because we need to have some logic for merging again the product items, but similar stuff. So let's see how the subscription in EventStoreDB is working. So again, we are using EventStore client, and we are saying that we would like to start and listen to events from the specific position. And this position we need to store somewhere. This might be a stream in EventStore, this might be a table or some other storage. But at first we are checking whether what's the current position for our subscription. And let's just switch for a moment to the slides. So what's the position? So for the specific stream, the position is auto-incremented. So as you see, we have streams for a specific shopping carts, and each event will have auto-incremented stream position. So 1, 2, 3, 4, right? For the other 1, 2, 3. But all those events are happening in some specific order. And in fact, they are not separate streams, but the single global append-only lock. And in this append-only lock, the position are gapless, but also incrementing. So this is also a number. So all stream contains all the events that were stored in EventStore. And we also have the position. So if we subscribing and we know that we already processed those 3 events, then we know that the last processed position is 130. If someone was using Kafka, then it's similar logic, because then you have a commit that you need to store somewhere, offset, commit offset, that you need to also store somewhere. And you might say that I would like to subscribe to Kafka from the specific offset. And the same is for EventStoreDB. So you are saying that you would like to subscribe from the specific position or from no position if you haven't subscribed yet. So that's the logic here. If you didn't subscribe, then a checkpoint is null. Then you are just saying that, okay, give me all the events. And for here, we are telling EventStore that we would like to get data from the specific position. And that's quite important because that enables resiliency, because if we process those events, then we don't need to process them again. And some failover and restarts might happen of our service. So we need to store it into some durable storage, and then subscribe to not process the same events again and again. If we would like to reprocess all of that, then we might just subscribe from the start, and that's all. And we are passing 2 methods. The most important is handle event. And we can check whether the event is not system event or checkpoint event. And then after we get this event and deserialize it, then we can publish it to internal event bus. An internal event bus, if someone was using Mediator, then this concept might be familiar, like the implementation might be notification handler, or we can create our own implementation. It just create new scope, get all the event handlers, and call all event handlers one by one. So that's quite, I think, easy to understand. An event handler is an interface. This is the only marker interface that we are using here that takes the event and some cancellation token and task, because that's also asynchronous. That's also for Prasad. So this is serious enterprise application. We are doing asynchronous code here. Just joking. So let's get back again to our documentation, or sorry, not documentation, but registration. And we can also define our projection with such a fluent syntax. This is code that I've written. It's on my GitHub. I will send link later on chat, but we will see briefly how it looks. Again, we are saying that for this read model and for this DB context, because as I mentioned, we'll be using event entity framework, Then for this event, we'll be adding new record, and we'll be using this handler that I showed you here. So again, like a pure function, almost pure function, because we are modifying the entity. And and for product item added, we'll be updating our read model. This is how we select the record ID from the event. This is the handler that we're using. And as this is details, then this is an entity framework specific. If there are some entity framework specialists here, then you know that code. It's used to eager load the other projection. The nested list. And again, for the shopping cart info, this will be even easier. Again, we are saying that we are adding and what we are updating. So let's see how that looks internally. So we have two classes that implement event handler. So add projection takes DB context, takes the our handler that you saw before. And again, if it gets even, then it's calling handler. And after that, it's adding entity and saving the changes. Right below, we have update projection, which is similar, but has a bit more logic. Get view ID is used to know which exact entity we have to load. So we are taking the ID from event and using it in the find async method. And prepare, it's just this load, so to enable loading nested collections. And after that, we are calling the handler and calling the save changes. So again, similar logic. For newly created, we take event, generate a read model and store it. And for update, we are loading the record, then running the handler, and again, storing the changes. So the same pattern could be exactly used for MongoDB or for other stuff. And let's see how that's glued together. Let's see again for our syntax. So we would like to say that for this specific read model and this DB context, I would like to handle events in such way that for shopping cart initialized, I would like to create new read model, and for the rest of events, I would like to update. So this is again in the same file. So we have single entry point where we are again registering all of that in the dependency injection container, and we are returning a builder, and the builder has the setup method, and the setup method is this one that you see here. So for will return us this lambda that we are passing here. And let's see again the builder, and the builder has methods like add-on, update on, and what it does, it just registers the handler. So the handler that we are injecting here. So our projection handler. And we are also registering iEvent handler. So this specific add projection, so our specific class. And so this can be for adding, this will be add projection that will, as I said, create new entity and store it. And for update on, again, we are registering some lambdas to get view ID, our handler for updating the state, and we are registering update projection with the as an event handler. So if we go back to subscription, then if we publish here an event, we got the notification from Event Store. Event handlers, all of the event handlers, so the add projection, update projection instances that we registered will be loaded here for this specific event. And then they will be just called one after another. So again, if we have a look on this registration, then the first lambda is that we are registering is how to get the read model ID from event. then our handler, which is again just a method that's updating the state. And after that, some pre-processing. And with this registration, we have a self-documenting code. As you see, no reflection. And we don't have, thanks to that, because the registration is strongly typed, then we don't have to use the marker interfaces in our business logic, because we are pushing the compiler checks on the edge, so on the registration, because this update on will make sure that the first lambda takes an event and returns object, so the ID. The other one will take event and view that we defined here. So it's not possible to inject method that has the signature that's different that we expect. So thanks for that. Our projection logic is clean. We could even unit test it or integration test it. And we have, but we still have compiler checks because of that. And we can also define the query width. And query width, it's for query handling. So again, we are adding some query handler, and query handler, we are registering our handler method. At first, we are getting the queryable, and thanks to that, we can use already no tracking, etc. And we are just calling the handler. So the specific handler can be like get card by ID. And this handler just takes iQueryable query object and runs some specific query. So that's quite clean, I think, I hope. And so in general, I wanted to show you today that event sourcing is not so scary as it might seem, as it pictured. Just to prove that it's like that, let me show you the controller, because we can still use controllers. So we can still use controllers. So we can take request, generate a comment, and we can inject here a handler that will be handling this comment. Again, the one that we registered before. So we can still use controllers. If we don't want to do the composability as I show you here, then you can also define interface like an iCommand handler. An iCommand handler, then you can create class per handler, you can create services. So you can compose it as you want, as you see, because it's not much different besides the getting the state and storing the state, because at first, we are getting events, then we are running business logic and storing a new event. So how we compose, we can do it in a preferred way as we would like to. It doesn't force us to use some magical stuff. As you see, there was only single place with reflection, just pure functions, so simple handlers, simple logic, simple code. So it doesn't have to be revolutionary. You might still, as you see, integrate it even with your current service, because you can build projections in entity framework that then will be used in other systems. In fact, I really encourage you to focus on using event sourcing where your business logic is the most sophisticated, where you can the most benefit from the history of operation. But even for the simple cases, as I mentioned, you can benefit from auditability, debugging, etc. As you saw, you can take a subset of events, as I did, sorry, not that IDE. So you can just take a subset of events even from the production system and run the business logic and debug and see what went wrong at which stage. So I hope that you will send the feedback, whether you find it as simple as I pictured that, as I hope that I pictured that. But in general, that's all. Thank you a lot for being here. I will answer those questions that appeared later on. The source codes, let me just find it. This is the repository, and there are multiple samples with the various styles. So I also other styles of doing CQRS in event sourcing than I showed here. So I encourage, but the one that I showed, everything is here on the on this pull request. I will merge it once I realize why the GitHub is complaining that tests are not passing. Surprisingly, on my local computer, they are working. But after that, I will merge it. So all the code that you see and also other methods are already here. And also you can have a look on my blog, where I yesterday published a blog post about the read models part I showed at the end. So you can get also information from there. And I would be really happy if you send me a feedback. You can contact me with my mail. You can leave me a message or tweet. I'm quite active on the internet, so you shouldn't have issues with finding me. So yeah, thank you a lot, especially for Joshua and Christopher for inviting me. That's a pleasure to be here, especially that I have a sentiment for Liverpool. I'm a huge The Beatles fan, and Jerzy Dudek from the Champions League at Istanbul. I think that we all also like him, at least if you are not an Everton fan. But yeah, so thank you a lot. I will answer the question in a minute.
Oskar, before we move into questions, just want to thank you again. It was an absolutely fantastic presentation. And if you ever want to as well, I think we'll have to get some flights over to Liverpool for any future presentations. So anyone watching this YouTube video, just like and subscribe, and yeah, check out our other videos. So we'll stop the video there. Thank you.